Okay, today we're going to do properties of logarithms. It's actually a long sounding word and a lot of explanation that is really not as difficult as it sounds. So hang in there as I go through a couple of these, and I think that you will see that it's not that big of a problem. It's really just more writing than it is difficulty. We actually have three rules we have that we're going to talk about. We have the product rule, which says that if we are multiplying something that's we're taking the log of, that we're going to end up adding those when we split it. Because what we want to do is we want to be able to take them apart and we want to be able to put them back together. If it says expand, that's what it means. It means that whatever is after your log and your base, whatever's in parentheses, you're going to be splitting that. So if I'm going to expand this, I'm going to say that keep the log, keep base of 3, but I'm going to split these two because this is 3 times x. So this is log base 3 of 3 plus log base 3 of x. So when we're talking about logs, our basic definition, let me write it here to the edge. If something equals the log and we have a letter here or a number and x, this right here is read as a base. Some of you will find it in your calculator at some point. If we look at math and we go to A, you see where it says base. And so if you enter that, if they're both numbers, you can actually put that in and find out what the number is. Okay, but if we're expanding it, we're not looking for an exact number. We're just wanting to write it in expanded form and then in condensed form. So this one has a base of 7. We're multiplying 2 times x. So we want to say that this is log base 7 of 2 plus log base 7 of x. And that's all you're doing. Have 3 things multiplied together. Notice there's not a number down here. If there's not a number there, this is always understood to be 10. And that's going to be important when we go to solving and rearranging logarithms, because we can write it as exponential form using that base. So if I understand that to be a 10, I can write the 10. I'm not going to count it wrong if you do, but normally if it's 10, we don't write it. So we're just going to say we have log base 10 of 5 plus log base 10 of x plus log base 10 of y. And so that would be expanded form. I actually think it says right here that if it's not indicated, it's assumed to be a base of 10. Okay, so this is expanding it. If I want to write it as a single log, I'm going to go the other way. So because this is plus, I'm doing this property the other way around. So if it's plus, I'm going to put those two things, the big number, not the base number, put the big number I'm taking the log of back together. So I'm going to write it as a single log. So log base 4 of 5 times x, which is simply log base 4 of 5x. The reason I wrote that separately, because if there are two numbers like this one, we're going to see it where we can then multiply them together. So remember, this is understood to be a base of 10, which we don't normally write. So I have my log of 15 times 4 because it came from plus, so I'm going to multiply them. And 15 times 4 is 60. Same thing with this one. These are all plus. So I'm going to write my log base 5 one time, and I have 6 times x times y. So it's just the opposite of what we did up here. Here we expanded them. Here we combined them back together. It says, notice that logarithms must be of the same base to combine them together. So like if one of these had a 4 and one of them had a 3, you couldn't do anything with that. Okay, they have to both have the same base number, or what would be your exponent number, to do that. Okay, so we're going to move on. We're going to do the same type idea, but we're going to do this where it says power rule. This one's really important. This says that if you have an exponent like that right there, it's going to come out to the front. So the logarithm of a power is that exponent times that logarithm. So it comes out from the exponent to the front. So if we're going to expand using this one, this is my exponent, so I've got to bring it out front. So this is going to be rewritten as 2 times log base 4 of x. Here's my exponent, bring it out front, 5 log base 7 of x. There's my exponent, bring it to the front, 5 log, and that would be a base 10. Looks kind of like a 1 there. It's an L. Should make them look like L's. Of b. So anytime I have an exponent, I'm going to bring that exponent out front of my logarithm. Okay, so if I go the other way, write it as a single log. If there's a number out front, this came from or goes to your exponent. So I'm going to bring it back up to an exponent. Log base 4 of x to the 7th. This is my exponent. It's got to go back up there. Log base 10 is understood of 4 to the x. This is my exponent, so I'm going to put it right there. Log base 5 of 6 to the 4th. You can leave your answers that way with it to the 4th power, because if we put that in our calculator, 6 to the 4th is a pretty big number, 1296. You could do that if some of you saw it that way, but I need to see this step first. I need to see the step that's right here that shows me that you put the exponent up top, and then you can simplify if you choose. Okay, but I need to see that part. Okay, so on the second page, where it says quotient rule, think about multiplying makes things bigger. So if we divide, not always with the decimal, but normally if we divide, then it's going to make it smaller. So we're going to subtract. It says it's of the dividend minus. Basically it means we're going to subtract. So if we're dividing, we're going to subtract. Numerator always comes first. Okay, so when we're splitting this up and expanding it, we're going to say log base 4 of the numerator. So we're going to write numerator first, minus log base 4 of the denominator. So when we expand it, we want the numerator minus the denominator. So here, this one's the numerator. Denominator, so I want log base 7 of 2 minus log base 7 of x. On 15, we've got log base 10, which is understood of b, minus log base 10 of c. So if we're dividing, that gives us subtraction on each of those. So therefore, if we're subtracting, we're going to go the opposite way. Remember, this is the numerator, this is the denominator. So when I write this as 1 log, or logarithm, short for logarithm, logarithm base 4 of x over 5, numerator over denominator. So here I've got an understood base of 10. That's my numerator, that's my denominator. So I have 4 over y. So this one I've got log base 5 of 6 over 3. I want to see this step. Then you can simplify if you want to and say that 6 divided by 3 is 2 is your most simplified form. So those are the three properties that we're talking about. Another page here. There we go. Multiplying, we're going to split them up and add or go the other way. If it's an exponent, it comes out front. Or if we are dividing, then we're going to subtract. These can be combined together to either expand or condense, which means rise a single log for each one. So if I'm going to expand this, think about what we have. For the numerator, we have 3 times x divided by y. So let's do it in that order. So we're going to take log base 8 of 3x minus log base 8 of y. Okay, so I'm keeping this together for right now. Numerator minus denominator. But then this part can be split up more. Remember, this part is multiplication, 3 times x. So I have log base 8 of 3. It's log base 8 of x minus log base 8 of y. So if I write it in this form, that tells me that these two came from the numerator, this came from the denominator. You may see some people that put parentheses around these two to show that's the numerator. If you do that, that's fine. Most of them it's not necessary, but some of them it makes it easier for us to see it when we're splitting it up. Okay, so think about what we have here. This is 5 times x to the second power. Okay, so let's think about this as log of 5 plus log of x squared. I want to split this first because I can't bring the 2 out front because the 2 is not with the 5. It's only with the x squared. Okay, so it can't come all the way out front of this one because it's not 5 squared. So I'm taking 5 times x squared, which is 5 plus log of x squared. Then I can say that this one has to come out front. When you have your simplified answer, we don't want to have any exponents or anything else that can be combined. Okay, so this is division. So let's write it out first. We have the log of x squared, numerator, minus log of y to the third, which is your denominator. And then I need to bring my exponents out to the front. So after we split this up, now this one has to come to the front. And they have to stay with their respective. 2 doesn't go with y and 3 doesn't go with the x. We have to keep them together. So we have 2 log of x minus 3 log of y. And try to write these as neatly as you can so that we can tell what they are. I know that it gets a little bit messy when you're talking about letters and numbers and everything combined. But when you're doing this on your notebook paper, either highlight your answers or try to write them in a box somewhere I can find it. Okay, so let's think about this one. This is 3 times x to the 4th times y to the 5th. So if I start out, I have log base 7 of 3 plus log base 7 of x to the 4th plus log base 7 of y to the 5th. Then we're going to bring our exponents, if we have it, out to the front. So the first one stays the same. Log base 7 of 3. The 4 comes in front for our middle one. And the 5 comes in front for the y. And there's our simplified answer. Remember, you can pause the video and go back and forth if you need to. That's the advantage of doing it this way. 23, we're going to go the other way. Write as a single log and simplify as possible. Okay, so first of all, we're going to undo this in the same order that we did. So if we looked up here, we split these up and then we brought the exponent out front. So I'm going to deal with the exponent first. This came from the 4 and this came from the x to the third. So we're going to say we have log of 4 to the second plus, we're going to keep the plus, log of x to the third. So first I'm going to do exponents. Put the exponents back as an exponent. Then we're going to do our rule. Well, this one is addition, which means it came from multiplication. So we're going to write as one log of 4 squared times x to the third. Well, 4 squared is 16, so I can say I have 16 x to the third. So this is your simplified form, and this is your expanded form. So expanded is written out, simplified is over here. Okay, notice this one has the parentheses here. This means that this part is the denominator, because this is minus whatever this is. So I'm going to start out by saying that this exponent has to go with the n. So we have log base 2 of m is the numerator part, divided by, on the bottom I've got log base 2 of 3, and notice this is another subtraction, 3 divided by n to the 5th. So I had this log up here, and then I have this part, which is another fraction part down here. This can be combined all together to say m divided by 3 over n to the 5th. So that's kind of messy, but if we thought about this way, I would first split it up, where I had log on top, log on bottom, and then do my subtraction and put the denominator in the parentheses. Okay, those are the hard part. This is the easy part. Used to, we had to do this change of base formula thing, which basically said if you had a number or letter down here, you would take the log of the number, the big number, divided by the log of the small number. You guys have a calculator, or you can get an online calculator and you don't have to do that, but we do want to round to 3 decimal places. So all you're going to have to do, this means that it's the log of 25 over the log of 2. And so if I was going to put it in the calculator that way, I would simply use my log key, which is right there beside the 7. So if I did the log of 25, use parentheses, divided by the log of 2, so it should look like this. Then I get my answer, which is 4.6438, so on. And so what I want to do is round it to 3 decimal places, 4.644. That's the way that we write logs. But if you've got one of these calculators, or you can find one, put it up here where we can see the light, you guys don't have to do that. You can simply go to math, right there, go down to A, which is right there, and put your numbers in. So if I want this one, I'm going to put 5 as my base number, and 12 is what I'm taking the log of, and there's my answer, 1.544. And I'm sure there's all kinds of log calculators on the internet that you can find too, if you don't have the graphing calculator or you don't have the app. I think there's pretty good apps now that you can get. So if I did this one, if I did math and I want 0.5 down here and 5 right there, I get negative negative 2.322. Okay, so the last one on here, if I do math, and I'm going to find my base is 2, that's negative 4. Notice it tells you an error message here, okay, which means that there's no solution. We're going to actually talk about this more when we're solving them later, but the reason why there's no solution here is because if I'm looking for some unknown, this can be rewritten as an exponent. So this actually means 2 to the x equals -4. Okay, well, there's no number that's going to give me a -4 if I have an exponent, because if I have positive exponents, I get a big number. If I have a negative exponent, I get a fraction. So there's no solution there. This is the reason why, is 2 to the x is not going to equal -4. And that's what it will look like in your calculator. Okay, so you guys can work on these. I want you to do, there's several problems on there on the assignment sheet, so I want you to do the even numbers is what I want. And I will put that on there when I assign that to you. Talk to you later.